Section 2.1, the least common multiple, also known as LCM, and the greatest common factor, also known as GCF. Let's start by talking about the multiples of a number. An example would be the multiples of 4. I have some listed below. 4 times 1, 4 times 2, times 3, times 4, times 5, times 6, and so on. The multiples are 4, 8, 12, 16, 20, 24, and so on. You're basically taking a number and multiplying it by 1, 2, 3, and so on. Okay, I'm going to define the LCM, or the least common multiple. The LCM is also known as the LCD, or the least common denominator, which is something you'll hear about when you add or subtract fractions that have unlike denominators. The LCM is simply the smallest common multiple of two or more numbers. So let's try an example. Let's find the LCM of the numbers 4 and 6. The answer is 12, because if you do multiples of 4, you're going to get 4 times 1, which is 4, times 2 is 8, times 3 is 12, and then if you look at 6, we have 6 times 1 is 6, times 2 is 12. They are common multiples. Here's my trick to find the LCM in an easy, quick way. Focus on the larger number if there are two numbers, or the largest number if there are more than two numbers. Let's go back to the example involving 4 and 6. Okay, the multiples of 4, as we said, were 4, 8, 12, etc. And 6 were 6, 12, etc. Notice with the larger number 6 that it only took us two multiples to get to our LCM, whereas with the number 4, which is the smaller of the two, it took us 3. This doesn't seem like a big deal right now, but if we were working with two larger numbers, it would definitely be worth your while. An alternative method to finding the LCM involves factor trees for both or all numbers. So let's go back to the 4 and 6. For the number 4, using a factor tree, we know that the prime factorization is 2 times 2, and the number 6 is 2 times 3. So what we want to do, now that we know the prime factorization, is take all the numbers from both prime factorizations and make sure that nothing is left out. Now if you look at the number 4 itself, we have 2 times 2, so both 2's definitely have to be part of your LCM. Notice that I have 2 times 2 written here. Now, once we have two 2's written, we can get rid of them or check them off. Okay, so those are both counted in our LCM. And if you look at the number 6, we have a 2, we only need one of them. It's already counted here. So we don't have to put 3, we only need 2. There's a maximum of 2 here, and there's actually only 1 2 here. Okay, so the number 4 is done, but the number 6 still has a 3, so we also have to include that in our LCM. Every number is now accounted for, so 2 times 2 times 3, which encompasses 4 and 6 without repeats, equals the number 12, which we said is our LCM. Okay, let's try an example. Find the least common multiple of 2, 5, and 8. Well, let's use the easy, quick way. Take the largest number 8 and calculate multiples of it, and see if you can figure out what the LCM is. Now, just to show you, if we were to work through all three numbers, in terms of the number 2, the multiples are 2, 4, 6, 8, and so on. 5 is 5, 10, 15, 20, 25, 30, and so on. But with 8, it only takes us 5 multiples to get to the LCM. 8, 16, 24, 32, and 40. 40 is the first multiple of 8 that also works for 5 and 2, and is the fastest to get to. Okay, let's try another example, but this time we're going to use factor trees. Let's find the LCM of 18, 54, and 63. If we used multiples of the numbers, it would be pretty tricky trying to find the multiples of 18, 54, and 63. So if we do the factor trees of all three numbers, for 18 we get 2 times 3 times 3. For 54 we get 2 times 3 times 3 times 3. And for 63 we get 3 times 3 times 7. So let's do the same thing. Well, we know that we have to include 2 because we have a 2 for 18 and a 2 for 54. So let me mark these ones off. Okay. Now, we need at least 3 3s because if you look at 54, there are 3 3s. So let's mark these off. And in the other two numbers, we only have 2 3s, but they're already accounted for, so we can check those off as well. And then finally, we have the number 7. Okay, so if you look at the LCM, we have 2 times 3 times 3 times 3 times 7. So ask yourself, in the number 18, is there 2 and are there 2 3s? Yes. In the number 54, is there 2 and are there 3 3s? Yes. And in the number 63, are there 2 3s and 1 7? Yes. So the LCM is 6 times 3, which is 18, times 3, which is 54, times 7, which is 378. Quite large, and it would take you a long time to do if you were to use the multiples. Let's talk about a common factor. A common factor is a number that is a factor of 2 or more numbers. Let's try an example. Let's compare the number 30 with the number 105. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And the factors of 105 are 1, 3, 5, 7, 15, 21, 35, and 105. Now, I have 4 sets of numbers circled between 30 and 105. They are 1, 3, 5, and 15. Those are the common factors between the two numbers. The number 15 in this particular case would be considered the GCF, or the greatest common factor between the two numbers. Let's try an example finding the GCF amongst 3 numbers. Let's find the GCF of 36, 60, and 72. Now, after much practice, you'll be able to find the GCF mentally just by thinking about the factors of the numbers given. But if you're having trouble doing that, take the largest number, in this case 72, write out the factors of it, and then starting with the largest number, 72, work your way down until you end up with the GCF. Now, let's start with 72. 72 obviously doesn't work because 36 and 60 do not have 72 as a factor. It's too large. 36 would work for the number 36, but not for the number 60. 36 is not a factor of 60. 24 also does not work. It does not work for either 36 or 60. 18 works for 36, but not 60. But the number 12 works for 36 and for 60, because 12 times 3 equals 36, and 12 times 5 equals 60. Therefore, 12 is the GCF amongst these 3 numbers. Let's try another example. Find the GCF of 11, 24, and 30. Well, again, I wrote out the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30. Starting with the largest number, 30, let's work our way down. Okay, the number 30 is obviously not the GCF because 11 and 24 are both smaller than 30, so they obviously cannot have 30 as a factor. 15 does not work. 10 does not work. 6 works for 24, but not 11. 5 does not work. 3 works for 24, but not 11. 2 works for 24, but not 11. 1 is the only factor that these 3 numbers have in common. So believe it or not, the number 1 is the GCF of these 3 numbers. The largest issue in this case is going to be the prime number 11.